So this lecture is on the binary search tree. So my goal is to build a binary search tree and basically do what's known as a tree traversal. Now, the way the binary search tree works, this is a root and the bottom here are known as leaves. So this is a leaf or leaves. And these are the levels, level 0, level 1, level 2, level 3. Now the maximum number of nodes per each level, so that's going to be according to the level. It's going to be, so level 3 here would be 2 to the third, which I cannot have more than 8 nodes on level 3. How is that? So this is 1, 2, 3, 4, 5, 6, 7, 8. So each node, if I want to find the maximum number of nodes on level 2 here would be 2 to the second, which is 4, 1, 2, 3, 4. Now, how do I build this? So this is a binary search tree. To build this, I start with 11. So 11 goes into as the root. Then I take 6, start with the root. Well, 6 is less than 11, 6 goes to the left, okay? Then I go with 8. Now check, start with the root. Is 8 less than 11? Yes. Then come to 6. Now 6 is 8 greater than 6 or 8 less than, so 8 happens to be greater than 6, so 8 goes to the right of 6. Then I take 19. Well, start with the root. 19 is greater, so therefore 19 goes to the right of 11, which is the root in this case. Okay, so now I pick up 4. The top of the root is 11, so 4 is less than. Then I take 6, second element here to the left. Well, 4 is less than 6, so 4 goes to the left. So I put 4 there. Now I take 10. Look at 10. 10 is less than 11. Come here, 10 is greater than 6. 10 is greater than 8, so 10 goes to the right of 8 because 10 is greater. So as you can see, the root here, so far every element on the left is greater, every element on the left is smaller, every element on the right is greater. So let's pick 5. 5 is less than 11, 5 is less than 6, 5 is greater than 4. So 5 goes to the right of 4, see? Okay, so now we pick 17. Well, 17 is definitely greater than 11. 17 is less than 19. So 17 goes to the left of 19 because it's smaller. Then you pick 43. Well, 43 is greater than 11. 43 is greater than 19. So definitely 43 goes to the right of 19. Now if I pick 49, I'm going to pick 49 is greater than 11, it's greater than 19, it's greater than 43. So 49 goes to the right of 43. 31 is greater than 11, it's greater than 19, it's less than 43. So 31 goes to the left. So as you can see, this is a subtree. The root is 43, the left is the left child here and the right child. Left child is smaller, right child is larger. So now we're going to traverse this, mean visit every node. Now the in order traversal or infix, it says left root right. So I'm going to start with the root. Left here, which is a subtree. Well, this happens to be a subtree. Then you go to the left. That is also a subtree. So, well, the subtree here is null. So there's no left pointer. So I'm going to go left. I visit the root. So that starts with 4. So once I visit left, root, right. So I go to the right, which is 5. Okay, so now I've gone left, root, right. According to this one, I'm going to backtrack it. This is recursive, so I go left, I go root, which is 6. Then I go right. That's a subtree. So I go left, which is null, and I go root, which is 8, and I go right, which is 10. See, I've gone left, root, right. I've gone left, root, right. According to this, I've gone left, I go root, which is 11. Then I go right. Well, that's a subtree. I go left, 17. And I go left, root, which is 19. And then I go right. Well, that's a subtree. So I go left, which is 31. I go root, which is 43. And I go right, which is definitely 49. So if you look at the in order traversal, it's 5, 4, 5, 6, 8, 10, 11, 17, 19, 32, 43, and 49. That's how, if you have to trace it. I mean, if you look at the code, it's really straightforward. Post order, that's postfix. This is sort of reverse Polish notation. Reverse Polish notation if you have a binary expression tree. This is left, right, root. So I'm going to start here. That's the root. Go left. That's a subtree. Go left. That's a subtree. So I'm going to go left, which is null. So left, right, which is going to print 5. So if I have left, right, root, then I do 4. Now I've gone left, right, root. I've gone left, right, but that's a subtree. So go left, which is null. I go right, which is 10. So left, right, root. Then I go 8. According to this, I've gone left, right, root, which is 6. Now I've gone left, I go right. Well, that's a subtree. I go left. That's 17. And then I go left, right. That's a subtree. I go left, which is 31. And I go right, which is 49. So according to this, I've gone left, right, root, which is 43. Now, you've gone left, right. Now you go root, which is 19. Then you backtrack, left, right, root, which is 11, see? So this is called the post order. 5, 4, 10, 8, 16, 17, 31, 49, 43, 19, and 11. That's post order. Now I'm going to do one more, which is pre-order, prefix. Prefix says root left. So root, okay, left, right. So that's prefix. So, I mean, in order, if you look back at this, this is like 5 plus 6. See, that's in order. Postfix is going to be plus 5, 6. See, that's postfix. Prefix is going to be 5, in this case 6 plus. That's the difference. So, so that would be the major differences. I will rewrite this. Okay, so this is, let's do the pre or prefix. Okay, so according to the prefix now, how does that work? So if you look back, so for prefix, it says root left, right. So I'm going to start with here. So that's going to be root. So that's 11. Root left, but that's a subtree. So do the root. That's a 6. Then do left. That's a subtree. So do root, which is 4. But you see, it's root left, where the left subtree is null. So root left, right. That's a 5. Okay. Now I've gone root left, right. So I've gone root left. I go right. Well, that's a subtree. So I go root, and I go root left, which is null. I go right, which is 10. Now I've gone to root left, right. So now I've gone root left, I go right. That's a subtree. So I go root, which is 19. I go left. Okay, that's a left job. So that's 17. So I go root left, right. Well, this is a subtree. So I go root, which is 43. I go left, which is 31. I go right, which is 49. And I'm done. And this traversal methods can be done recursively It's really very straightforward, and thank you for listening to my video, and we'll be very grateful. Thank you.